Well, this is chapter 4, control structures, selection. In this chapter, you learn about control structures, examine relational operators, discover how to use selection control structures if else, examine the int and bool data types and logical Boolean expressions, examine logical operators, explore how to form and evaluate logical Boolean expressions. Learn how the relational operators work with the string type, become aware of short circuit evaluation, learn how the conditional operator, the question mark, colon works, learn how to use pseudocode to develop, test, and debug a program, discover how to use switch statement, learn how to avoid bugs by avoiding partially understood concepts, and learn how to use the assert function to terminate a program. Now, a control structure is like a selection or repetition. Selection be where you're choosing to do part of the code. If this is true, then do this part of the code. Else do this part of the code. Repetition is where you're repeating the code over and over. Maybe you're asking the user for the input over and over. And I'm not going to go through all of this. Because they go in a lot of detail. You can read the book and get a lot of this. So I'm skipping down to the important parts here. Here's the relational operators in C++. If you've taken any kind of programming language, it's the standard equals equals equals. Exclamation equals not equal to, less than equal to, greater than equal to is just what you'd think. Now you can compare a variable to a variable. You can compare a variable to a number. You probably can compare a number to a number. I think I ever tried it. If 3 is less than 5. 3 is less than 5. So yeah, I guess you can do numbers. It wouldn't make any sense because it's always true or it's always false. Always a variable's involved in reality. Now, what these give you is they return true or false. It's like this: 3 is less than 5. That's either going to return true or false. In this case, 3 is less than 5, so this will return true. In an expression of character values using relational operators, the results depend on the machine's collating a sequence, the ASCII character set. Logical Boolean expressions includes expressions such as 4 is less than 6, and capital R is greater than capital T. If you're wondering, well, how does it know which one's greater when you got letters or weird characters or whatever? It comes over here and goes off of our ASCII table. And so if I'm comparing A to little a, for example, the decimal equivalent of capital A is 65. The decimal equivalent of little a is 97. So it treats those like numbers when it does the comparison, like R and T. Big R is 82, and T is 84. So R is not greater than T, so that'd be a false. And again, they indicate the integer values 1 and 0, true and false. Now we'll use this to do a one-way selection. So if, and then you got expression here. Okay, so I decided to go ahead and use part of this, but let's see. I'll change this to a grade program here shortly, but okay, so we're inputting number 1, number 2. Remember, we're adding them together and coming up with a sum. If the sum is greater than 50, then I want to print that something. So if sum is greater than 50, then I'll have Cout. The sum is more than 50. So if I run this, 20 and 32, sum is 52. It says sum is more than 50. So comes down here, it's sequentially doing these lines of code, one after the other. It hits this if statement. And this is the exact same principle as it would be in real life. If I'm hungry, I'll go eat. If I have to go to work, I'll get up in the morning and drive in. So there could be more than one line even. Now, it checks this. It retrieves the value of sum, which was 52 in the example I just ran. 52 is greater than 50, which is true. Since this is true, it'll do this line of code right here. Now, if you want to have more than one line of code, then you use braces. So you put braces there. And then you could have another one. That is a big number. And then indel. If you have one line of code, you do not need the braces. And you see it does both of them. Now, if it's false, so if I were to run this and it comes down here and this is not true, if it's false, then it drops down after the this curly brace and does the next line of code, which there isn't any, so it means it'd be done. So it will only do these lines of code if this is true. And I'm going to close that. You can also have an else statement there. So if this is true, do this, else do this. So if I come down here, if it's not greater than 50, I'll have an else statement, and I'll have 2 lines of code, so I'll put curly braces. Cout, the sum is less than or equal to 50. Cout, that is not a big number. Indel. So if I run that, 2, 3, so the sum is 5, the sum is less than or equal to 50, that is not a big number. So it comes down here, and it's going sequentially. This is why it's called a control structure. It controls the flow of the program, though there are some other ways we can control it also. Comes down here, it checks this. In my last example, it was not greater than 50. So since this is not true, it comes down here, and the else is done if this is not true. And so it comes down here and does these 2 lines of code by default. We have another new data type called bool, and Boolean returns true or false, and we'll talk more about that. For logical Boolean operators, these allow you to combine logical expressions. This is the exclamation, not, the two ampersands, the two and symbols, and two pipe symbols, the or. And I want to get to the kind of nesting. We'll talk more about those. They give you a new precedence of the operators, order of, like order of operations from college algebra, with programming part thrown in. Not sure where they have it, but I'll show it. There's different ways you can do this, and we're gonna look at a couple different ways. What we're gonna do is we're gonna find the average. All these are grades, for example. So we'll have grade 1, grade 2, grade 3. Then we're gonna have the average. Now, since these are all worth 100, and my average is going to give us whatever value, we then need to see whether they got an A, B, C, so forth. Okay, so first thing I'm going to do is input grade 1. I'll input grade 2. Then I'll input grade 3. Now calculate the average. Now the average means to add them together and divide by 3. Now let's say from college algebra you're not too good. You're not too good in order of operations. In programming, we call that order of precedence. If you come over, you can, of course, use this chart, and this would tell you that, well, this plus here is a little bit different. This and the minus refers to the unary operators. That is not addition and subtraction. So when you look at this, you see that it does division first. So it'll do this first, and that's not what we want. You see plus comes after that. Well, how you control that is by using parentheses. If you put parentheses around this part right here, just like in algebra, you're forcing it to do the addition first. I think in algebra is please excuse my dear Aunt Sally, please do whatever's inside the parentheses. So you do that first. Okay, so now we got our average figured. And I want to print out my grading. So if the average is greater than or equal to 90, that means they got an A. So I'll say Cout, you got an A. And it really does help if you print out the average so you see if it's working. I was doing this in another language and I didn't print out the average, and I really never knew if it was working because I didn't print it out. Okay, so C out, set precision, can't spell, and average, Endo. Okay, so now I'm going to say if average is greater than or equal to 80, and you can use these symbols. This is the and. Average is less than 90. This is our first technique of showing this. What this will do then is get everything from 80 all the way up to 90, not including 90. So get, for example, 89.99 would be a B. If average is greater than or equal to 70, and the average is less than 80, then I'll print out, you got a C. If the average is greater than or equal to 60, and the average is less than 70, got a D. And if average is below 60 is an F. So I'm going to say less than 60. You got an F. So let's run this and see if it works. Let's see, 90, 88, 93. Let's do an integer division. Do you know, what do I do to change that to get it to work? I could, or just simply doing the 0.0 there would. Let's see, 90, 88, 93. And then we get our decimal. That's what you have to be careful of when you're mixing integers and doubles together, is if everything's an integer, it's doing integer division. If one of them is a double, then you can think of it as promoting the entire thing to a double. Like you indicated, I could make these a double if their grade's going to actually be have decimals. Why wouldn't I just go ahead and make them a double? Wouldn't that be easier than to handle any possibility? It does. And now usually I don't care about that. I'm kind of a sloppy programmer. But if you're programming because I'm a Windows programmer and it's got plenty of memory. But if you're programming for a device that does not have much memory, then you don't want to just use the largest data type that you can. You want to keep it as small as possible, so it uses as little RAM as necessary. Okay, now that's one way to do the average, and that shows you the usage of the and here. Another way. Let's see, if average is greater than or equal to 90, that hasn't changed. See out, you get out of the name. else if the average is greater than or equal to 80, see out, you got a B. Else if the average is greater than or equal to 70, see out, you got a C. Else if average is greater than or equal to 60, you got a D. Else, none above is true, you got an F. So you look at this, and you look at this, you say, well, that looks like to me about the same amount of work. Yeah, it is. Up here, it's having to check this, returns true or false. It's also having to check this, returns true or false. And then it has to do the AND here. So there's three operations happening right there with that check, versus down here, it's just doing one operation. It's checking to see if average is greater than or equal to 80. So the code down below is actually more efficient. I would say it runs faster, and in theory it does, but not so you would probably notice it. You run it on Windows, and probably saves you 0.001 microseconds or something. It's a trivial amount that it would save. Now, again, if you're working with some place that does not have the processing power of Windows, then maybe it would be significant. Or if I was doing this 5 million times, you take 5 million times your 0.001 or something like that. Let's see what that gives you. One, two, three. Okay, times. Let's say it was saving you 0.01 seconds. You take that times 5 million, and all of a sudden it's 50,000. Yeah, 50,000 seconds. I don't know how many minutes that is. Let's see. About 60. That's that many minutes. Seconds. And this divided by 60. Give me how many hours? And I don't know if the time savings is 0.01 seconds or not. I'm just using that as an example. You see, all of a sudden, if we're doing processing, it takes us 5 million. Some of you go into computer science degrees, and you may work on scientific applications that go through and process 5 million times. Maybe you're doing if you've taken Calc 2, if you've covered series, maybe you're going through and doing something that's you need to test it out 5 million iterations. Well, at that point, you see that it's no longer trivial. We've actually saved about 14 hours by maybe programming it correctly. Okay, I don't program those kind of applications. I do simple ones. So, but I want to point that out. I do know the savings involved. One of the classes you'll take is studies optimization. They got this big O type of. It's a whole study on time savings, efficiency. O notation. I'll make sure I put programming in front of that. Let's see. See, in computer science, big O notation is used to classify algorithms according to how their running time or space requirements grow as the input size grows. So again, just different factors that it'll study for efficiency. Okay, so you saw two different ways that I can do that if, else if, or else structure. there any questions on that? Okay. Strings are always a little bit different, so I'll go ahead and mention this here. Strings are compared character by character, starting with the first character. Comparison continues to either mismatch is found or all characters are found equal. If two strings of different length are compared and the comparison is equal to the last character of the shorter string, so it does. Yes. Yeah, the uppercase and lowercase would not be the same. But then the shorter string is less than the larger string. It's always a good idea when you're programming a string in your application, you do some testing and just see if you know how everything works. See, here's the expression string 1 is less than string 2. And so it comes here and it compares the first letter, which is the same. Then it comes to the second letter, the E and the I. And if I look over an ASCII table, the E is less than the I, decimal wise, which means this returns true. Now, if it's done correctly, then the program doesn't have to compare any other characters, because the first one it runs across causes it to be true. Now this one is comparing string 1 and see if it's greater than hen. Now first letter here is H, matches that. Goes to the second letter, E, which matches that. Goes to the next letter, L, and that's N. Well, L, I'm pretty sure my ASCII table is less than N, so that's why this returns false. Does that kind of make sense on that? Okay. You just if you ever draw a blank, you just go to the ASCII table and you see how they compare. Whereas it is, you can compare things that have these special characters here. What's even worse is somehow when there's an invisible character that gets in there, like a horizontal tab, because you see that has a decimal of 9, which would be less than everything else, wouldn't it? Now they do have ways you can put invisible characters in a string. I'm not sure if I can do it in code blocks, but let me see. So I have to bring in string test equals. Yes. Yeah, you can bring it in also. Now, we say get line versus the CN. You mean use that instead of the CN? Let's see. I don't think you need to use the get line, but at least maybe I'm remembering wrong. Languages all start running together. Okay. Okay, space marks up. So get line. I have to look up the syntax on that. I'm trying to remember. Get line. Obviously, that isn't it. You remember the syntax? Okay. I don't remember. What a sheet. Sometimes I can read the documentation and it comes to C++, sometimes not. I think I remember it because I think I brought this up last week. Example. CN. I didn't put that in there. Okay, so get line CN test 2. Oops. 3. Now CN comes first, then your name. Oh, you mean just a generic CN? Um, hmm. Because of the CNs I have up here, you mean? Let's see. Well, that example I had out there, you don't. But if you have CNs above it, then it doesn't work. So, do you do a CN to a dummy variable or? Yeah, I just can't remember how to clear out the buffer. I don't know. I'll have to, do some looking into that. But anyway, got our comparisons there. Right. And here, got hello and lowercase h and uppercase h. They're comes back and says they're not equal because, like you just indicated, little h is decimal equivalent 104. Big H is 72. So anyway, I won't go through all these examples. I think you kind of get the idea on that. Now we already talked about the use of the curly braces. There's an example. We already talked about this where you can nest them. Else if, else if. Um, Oh, I didn't talk about what's happening. When this comes down here, let's say that I go through and do these lines of code. My average comes out as 73. It comes down here and checks this, sees if that's true. If it's true, it does this. Comes down here, checks this. It'll check this whether the above was true or not. It'll check this each time. So it's even worse than what I mentioned because I didn't take into account. It's not only checking just the one, it's checking every one of these. So there's 1, 2, or there's 3 there, 3, 6, 9, 10. There's 11 operations being done, which means instead of well, I erased it, but instead of that 14 hours extra time, that could be very significant. Now, on the other hand, what did I do? Delete it? See how far back my history goes. On this example, if for example, 72 comes down here, checks this, it's not greater than or equal to 90, so it comes down to next else, checks this, it's not greater than or equal to 80, so it comes down here and checks this, and it is greater than or equal to 70, 72, so it prints you got a C, and at that point, it drops out of the else if structure and comes down here, so we'll not even do the checks down below it. This is the efficient way. If you got multiple selections being done like that, you should nest them with else if, not do them like this. Now, I see all kinds of variations like this when people want to check for the largest number. They'll say if this number is less than this, if this number is less than this. And there's more creative ways to do it. I never take points off for it or anything, but you don't really have to think too much about optimization to later programming classes. Let's see. Too exciting there. Short circuit evaluation. Evaluation of a logical expression stops as soon as the value of the expression is known. So we got these the following expressions. We're comparing age is greater than or equal to 21 or x is equal to 5. So if either one of those is true, this one is the and, so both are true. Does that make sense? If one of them is false, then it might stop. Okay. Because if this one's, for example, this one's not true, then it doesn't even need to check this one. The or is a little bit different because it does have check both of them. Okay. Comparison of floating point numbers for equality may not behave as you would expect. I don't know what programming class it was in. I was doing a simple operation, and it threw an extra decimal place clear out, like 9 places out. And so an equals there might not be quite correct. And okay, I think about this for a minute. My basic fractions: 3 7s plus 2 7s plus 2 7s is 7 7s, which is 1. So I should come back as true, but it evaluates false. And they say because when you plug this in, it has this value. So it's not equal to 1. Solution is checking for a tolerance level. So you're checking if the floating point absolute value of x minus y is less than this value right here. So you just want to check to see if there's an error involved with the calculation. Enter an integer. This is showing where you could check for valid input. So you can use if statements for that. For example, if I'm up here and I want to check for valid input. So they bring in grade 1, and I'm going to check if grade 1 is greater than or equal to 0 and grade 1 is less than or equal to 100. If that's true, then the data input is valid. If it's false, then I want to perhaps handle something else. Now, I really want to check to see if they entered something invalid. So I did this on purpose. How can I change this easily such that it's the opposite? Yeah. Nope. Exclamation. This is so powerful in programming. I mentioned it, didn't really talk much about it, but oftentimes you don't want to take the effort to try to figure out what the opposite of that is. So this says if that's not true, then see out bad input. For example, if I put that, tells me bad input. Still goes through and gathers it, so I'd have to do another check. Now, how it's written correctly, if grade 1 is less than 0 or grade 1 is greater than 100. That's how it's correctly written. Because you can't have a grade 1 less than 0, can't have one greater than 100. And then you would print out bad input. They teach you this. You have to take usually if you go to computer science at a four-year college, they'll have you take like a discrete math, discrete structures class. And they cover how do you negate something. When you got something and something else, you change the and to an or, and then these go to the opposite. So for example, they give you these kind. If you got sunny and happy. What would the opposite of that be? Well, it could just be cloudy. So actually not sunny or not happy. Now, if there was just two like sunny and rainy and happy and sad, then you'd be correct. But that's what you cover. Most of that I've forgotten. The only thing I really remember is how to switch an and to an or. But they anticipate a lot of programmers have forgot it, so they put this nice little negation symbol on there. Okay. What's wrong with this? Yeah. Double equals. This, I don't know how many times this caught me over the years. This is the assignment operator. You see, it says it's not a syntax error, it is a logic error. Because it'll come here and it'll assign 5 to x, just like when you say x equals 5. And it'll always return true. So this will always print this no matter what. So yeah, you want two equals. You can read about this in the book. I really don't like it. It's kind of a shortcut way to write an if statement. Um, yeah, I think it's not a good. Um, in case you're curious what it does, here's the if part. Like if A is greater than or equal to B. If that's true, then this value is returned to max. If it's false, this value is returned to max. If you like it, you'll see examples in the book on that. You're welcome to use it. You'll never see me use one of those. I never have. Yeah, it's you can read it and it's just self-documenting. You don't have to think, well, what does that do exactly? Make sure you use indentation. Um, I was going to take points off, or I was going to make a comment on somebody's that had used some weird indentation when I was grading, but it was a different indentation than mine, and it might have been something that worked for them. And that's all that matters. Pick one that works for yourself. Sure, blank lines. So it's just talking about coming up with some kind of mechanism to make it more readable for yourself and for future people. Um, Pseudocode is more if you got a more complex program, you kind of come up with your own little language of trying to walk through how it should be written. Here's a switch structure, and I'm not real crazy about these, but you're welcome to use it. It's kind of a taking the if else like the structure I did earlier and come up with a shorthand way of doing it. So here's the switch and here's the expression. This is like saying if, and then you got your expression like a variable or something, and then is equal to value 1, then do this. If it's equal to value 2, do this. If it's equal to value n, do this. And then if it's not equal to any of the above, then you do this. Now there are some that I do like, some that have fairly powerful. And I don't remember if C++ is one of them. We'll see with the example. You see how this puts letters here? So that's not bad. And let's see if I can do it another way. Oops. Now, where's the beginning curly brace? Yes. Not case, switch. Case, red, colon, colon. See out, it is red. Break. This is why I don't like switch statements. You see that it says cannot convert red from the constant character type error. No match for the operator, assuming I put everything else right. Character C equals to R. Yeah, maybe I got something else wrong. Switch. Oh. I got those going the wrong way. Oh, end. Sure, I should read my errors. Okay, so let's go back to the string. Color. Okay. This is why I don't like switch statements, is because they don't work based upon strings. They work based upon numbers, like integers, and they work based upon characters, which are integers. Because remember, a character corresponds directly to an integer number, this decimal. There is one or two programming languages that I've used that can use strings and switch case statements. So I like that, but it seems so limiting if I can't do any of the other data types. Some will let you even do, like if I did the color or this. First, let's just see if it allows 3.11. Doesn't like doubles. But some programming languages allow you to put things like this, where and that's powerful. But that's the switch statement. I just based upon one particular type, which I think is very limiting. Talks about how to stop an error. I'm running out of time, so I guess I'm at the end. But anyway, cert we'll talk more about later on when we get into exception handling. But allows you to handle errors appropriately instead of letting your program blow up. Well, we're done with that chapter. So I'll pick some problems out of there, and I'll put the test for all the sections in Blackboard. No longer use MindTap for that. So Dawson, this time you shouldn't see two tests out there. Apologize for that confusion. I couldn't get. I finally figured out how to get rid of it. But I got rid of it in the grade book. Like if you saw it in one place, but if you went and looked, you didn't see it in the grade book. But now it's out of both places there. Yeah, I saw that, and yeah, MindTap is how it integrates isn't very pleasing to Blackboard anyway. Well, we'll go ahead and stop there. Is there any questions or anything? Where it repeats the code? Oh yeah, I hadn't figured that one out. Yeah, because it prints all of your code you did first, right? And then no, I can't figure that out. I'm still looking at it. It did it to me once this morning. And then when I fixed an error, it didn't print my code anymore. So I'm quite confused on why that is. But I couldn't tell you why the program prints also in that. Yeah, go ahead and turn that in. Yeah, because that is the right output. It's just you're printing your code right above it. So, okay. Yeah, that sounds good. Because that was multiplying numbers anyway. So,
Right. I did the sum example in class.